So, good evening, everyone. Welcome to lecture 20 of the course on data structure and algorithm. In the last class, we have discussed about polynomial addition. In this class, we will discuss about polynomial multiplication. I'm sharing my screen. Hope you can see my screen. So, can you see my screen?
Yes, sir.
Oh, right. So, this is about polynomial multiplication. Addition. Okay, let me just mm, uh, brief again what is addition. So the addition algorithm is very simple to understand. So one by one term in polynomial 1 and polynomial 2 you are comparing. Term you are comparing means you are basically comparing the powers of the variable. For example, you are starting from the first term of a polynomial. So the first term of this polynomial 1 is 2 x to the power 9, and the first term of the second polynomial is x to the power 4. So you are comparing the power of the first term, that is 9, with the power in the first term of the second polynomial. So if this power is more than that, then you are what you are doing, this term will be straightforward the first term of the resultant polynomial. Okay, if this power is less than the power of this term, then this term will be the finalized first term of the resultant polynomial. And if the powers of this term and this term are equal, then these two terms of the polynomials are actually like terms. So in that case, you are supposed to add their corresponding coefficients. Okay, so the resultant coefficient will be the coefficient, okay, corresponding to that term, and power will be the same because the powers are same, right? For example, here 4x to the power 4 and x to the power 4, so these two are like terms, so their powers are being compared, and after comparison they are found that they are equal. So what will happen, their coefficients will be simply added. So 4 and here 1, so 4 plus 1 5, so 5 will be the resultant coefficient of the resultant term. Okay, and or the overall term will be 5 into x to the power 4, x to the power 4, x to the power what power, power either of this term or this term, because both these two powers are same. So this is the logic, how do we add terms of two polynomials. And that algorithm was a generalized algorithm for any two polynomials. That algorithm is capable of adding to any polynomials of any degrees of with any number of terms, right? Now coming to polynomial multiplication, so let's understand the mathematical logic first. Once we understand the logic, rest is not a big deal. So consider two polynomials, p1 equal to x square plus x plus 1 and p2 equal to x minus 1, and we know if we product these two polynomials, x minus 1 into x square plus x plus 1, we know that it's a very standard formula, it will come up to x cube minus 1, right? So let's see. Okay, and also interestingly, this example has been taken to show you the power of the logic, because the I mean, if you understand the logic, you will see the number of terms in the resultant polynomial supposed to be large, but actually the number of terms in this case is 2 in the result, x minus 1 into x square plus x plus 1. What is the result? X cube minus 1. So how many terms are there in the result? 2. Right, so see, so multiplication is shown and below. So how will you multiply? The logic is, so x square plus x plus 1, okay, so I'm actually feeling a little bit of irritation because I'm not feeling well, so I'm trying my best. So uh, first polynomial is x square plus x plus 1, the second polynomial is x minus 1, and we are trying to product them, multiply them. So the logic is, first this x square term of the first polynomial must be multiplied with all the terms of the second polynomial. This is your polynomial number 1, first polynomial. This is polynomial 2, second polynomial. So the first term will be multiplied with all the terms in the second polynomial. So x square into x, and then minus is due to this minus. Okay, so minus x square into 1. Okay, so x square into x minus x square into 1. X square into x minus x square into 1. Okay, that's what we have written here. So multiply x square with all terms in P2. P2 means second polynomial, to get a temporary polynomial T31. So if you do this first bracket portion, you are getting. So if you multiply x square with all the terms in the second polynomial, you will get a temporary polynomial, other polynomial. So that is your temporary polynomial. And suppose we are denoting this temporary polynomial by this notation PT31. P1 for first polynomial, P2 for second polynomial, and P3 for third polynomial. Third polynomial is resultant polynomial. P3 for resultant polynomial. And this is the first term of the resultant polynomial. That is why T31, 3 for resultant polynomial, and T1 for term 1, first term. So PT31. Next, similarly, this x term of the first will be multiplied by with all the terms of the second. So x into x minus x into 1. So x into x minus x into 1. Again, it's a temporary polynomial, and let's say it's PT32, second term of third polynomial. What happened? So next one is getting multiplied with x minus 1 is getting multiplied with 1. So 1 into x minus 1 into 1. And that temporary polynomial is actually the third term of the resultant polynomial, PT33. Okay, so how many terms in the first? 3, right? Okay, so the number of terms in the first polynomial is 3. And that's why you are getting 3 such brackets: T31, T32, T33. This is
a temporary polynomial, right?
Yes.
Number of them.
So how many, if we call these brackets as temporary polynomials, so 3 temporary polynomials you will get. Why 3? Because number of terms in the first poly is 3. This is very clear, right? What happened to these persons? So number of terms in poly 1 is equal to, let's say, n. Number of terms in poly 2 is equal to, let's say, m. So then I can say that then number of temporary polynomials is equal to n. Is it? Okay. Now let's understand this convention based on this example, and it can be further generalized, no issue. Now, how many terms are present inside each of these temporary polynomials? In this example,
M.
2.
Yes, in this example 2.
This is 1, this is 1. So total it's 2. It is 1, it is 1. Total it is 2. This is 1, this is 1. Total it is 2. So in each of this temporary polynomial, number of terms is 2. So number of terms in each temporary poly is equal to m. Okay, so that is fine. Okay, now you have calculated such temporary polynomials. This bracket, this bracket, this bracket. PT31, PT32, PT33. And then you have to sum up all these temporary polynomials. So this first temporary polynomial is getting added with the second temporary polynomial, and that is getting added with the third temporary polynomial. So the resulting polynomial is nothing but the summation of PT31, PT32, PT33. Okay, in general, PT31, PT32, PT33, and comma dot dot dot, like that. Right? Now, how can you add such temporary polynomials? And you have already developed algorithm for polynomial addition. So just call that polynomial addition, and using the help of that polynomial addition, add these two poly, get the result, then add that result with the third poly, and so on. So by using the polynomial addition algorithm, you can compute this addition, summation of polynomials. Okay, so here you are using the polynomial addition algorithm. ठीक है? Okay, so this summation is done. It is possible. Now let's have a closer look on how shall we construct each of these temporary polynomials. So each of these temporary polynomials are nothing but, okay, multiplication of one term in poly 1 with all the terms in poly 2. ঠিক আছে? So that means x square into x minus x square into 1. So if you have here in the second poly, so how many terms in each of the temporary polynomial you will have? Here it is 2, because the number of terms in the second poly is 2. That's why these two terms are present. So x square is getting multiplied with x, 1 multiplication. X square is getting multiplied with 1, second multiplication. So how many multiplications you are doing? 2. Why 2? Because the number of terms in the poly 2 is 2. If poly 2 polynomial, second polynomial contains 4 terms, then 4 such multiplications you have to perform. So if there are m, small m, Mumbai, m number of terms present in the second polynomial, then you have to perform small m number of multiplications to construct one temporary polynomial. That means repeatedly you are performing multiplications, so you require a loop to construct one such temporary polynomial. And what is that one such temporary polynomial? It's nothing but a single term of a resultant polynomial. T31, T32, T33, dot dot dot. So TP3I, oh sorry, yeah, TP3I means each term of the resultant requires a loop. Repeated multiplication you have to perform. This loop should be repeated for all the terms in P1. So are nested. See, so this is one loop. Using a single loop, you can construct one term, right? So how many such terms you have to compute? Temporary polynomials you have to compute? 1, 2, 3. So 3 times, right? বোঝা যাচ্ছে কিছু? ক্লিয়ার হয়েছে? একটা
Yes, sir.
একটা টেম্পোরারি পলিনোমিয়াল কি করে ক্যালকুলেট করব? একটা temporary polynomial, one temporary polynomial. So you consider any one term in poly 1, multiply that term with all the terms in poly 2. So you require a loop. For example, this x square, and here how many terms are there? 2, x and minus 1. So you are using a loop. You are multiplying x square with x and x square with minus 1 to construct each such temporary polynomial. This temporary polynomial are nothing but term of the resultant polynomial, right? So to construct each such temporary polynomial or term of the resultant polynomial, you require a single loop. And how many such temporary polynomials you have to construct? In this case, 3. Why 3? Because the number of terms in poly 1 is 3. So 3 such temporary polynomials or 3 terms of the resultant polynomial you have to construct, you have to compute. And for that purpose, you require another loop. So loop inside another loop you require. That's why we come up to this position that we require a nested for loop. The outer for loop should be controlling the number of terms in the resultant polynomial. In this case, it is 3. And the inner for loop is supposed to construct each such temporary polynomial. So outer for loop is running for 3 times. Inner for loop is running for 2 times. That's it. Total of 6 number of times. Right? You see 1, 2, 3, 4, 5, 6. Okay. So this is the thing. Algorithm development in general, let's say now we can generalize it further. So in general, 2 polynomials are written as like this. Let's say the polynomial 1 p1 is equal to a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus dot 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 n minus 1 x plus n. Normally here you can see that one sign is minus in the second polynomial. So how to deal with that? Whenever you will ask the user to provide polynomial inputs, you are taking inputs from the user, right? Polynomial 1 and polynomial 2. So by default, the sign of the coefficients are positive. You are assuming that. And if, I mean to say, this x minus 1, you will treat this x minus 1 as like this, x plus minus 1, like this. Okay, so that means what? All the coefficients are assumed to have positive sign. So this is plus 1 multiplied with x, right? Similarly here, minus 1 is getting multiplied with x to the power 0. And this is x to the power 1. This is how we used to represent a polynomial while taking inputs from the user. So user is supposed to provide plus 1 and plus 1. Next, of course, powers are positive integers. Okay, non-negative integers. Achha. Then user will provide minus 1 coefficient and 0 coefficient. And these 2 terms are added. So this is a plus. So this is how you can construct a polynomial x minus 1, right? So you don't have to bother about the minus sign. User will provide that minus sign. User will take care of that minus sign. You as a programmer will consider that all the terms are being added. You don't have to think that these 2 terms are subtracted. You don't have to perform subtraction, x and minus 1. Okay, the x plus minus 1. So make it very clear. Now, algorithm development. In general, 2 polynomials are written like this. The first polynomial is having degree n, and the second polynomial is of degree m. So there is a slight mistake. It should be n plus 1. So in polynomial 1, in polynomial 2, we want to understand some notations, number of terms in the first polynomial is n plus 1. It should be n plus 1. Okay, and here number of terms will be m plus 1. Okay, so make it correct, please. So each term of the polynomial is denoted by T1i. T1 for term in first polynomial, and which term, that is given by index I. Okay, each term in second polynomial is denoted by T2j. 2 stands for second polynomial, T stands for term. So term of second polynomial. Which term of second polynomial? Jth term of second polynomial. J is the index. And each such term T1i is consists of C1i and exp1i, where C1i is the coefficient, exp1i is the exponent. Similarly, T2j consists of C2j, exp2j. Here j is the index, I is the index. We may take yes, we have taken different indices for better, without to avoid confusion. Now resultant polynomial P3, maximum number of terms should be it's a mistake, so it should be m plus 1 plus n plus 1, that is m plus n plus 2. So please make a correction with this. Each term will be here, it's actually cropped, I'm just dictating. It should be T3R. Okay, T3 means third polynomial, 3 for third polynomial, 3 for P3, and T for term, and Rth term of third polynomial, so T3R. So each T3R is consists of C3R, and it should be exp3R. Index R is being used here. So initialize, I mean, initialize temp R equal to 0 for all R in temp comma P. Means temp R means Rth temporary polynomial. So here you are constructing several temporary polynomials, which are nothing but terms of the final result, final polynomial, resultant polynomial. So Rth such temporary polynomial is being denoted by temp R. Temp R. So initially you are resetting all the values, temp R equal to 0 for all R in temp. Okay. Next, for all R in capital R P3, that means R is the resultant polynomial or P3, whatever. Okay.
আচ্ছা স্যার একটা জিনিস একটু ডাউট ছিল
হ্যাঁ
স্যার ওই যে ওই যেটাতে লিখেছে যে
my mistake, T3R denotes the rth temporary polynomial. ঠিক আছে, rth temporary polynomial of মানে third polynomial, ঠিক আছে, T3R. P temp R are temporary variables, ঠিক আছে, P are মানে these are not actually P1 P2 or P3, ঠিক আছে, নোটেশনটা একটু দেখে নাও, এটা হচ্ছে P1, এটা হচ্ছে P2, a resultant polynomial is P3. So P3 will have several terms, each of such term is denoted by T3R. So you are initializing all such T3R equal to 0 for all R in P3 or capital R, ঠিক আছে, and these two will be used for intermediate calculations. These two variables P and temp R, those are also being initialized to 0. That's why. Okay.
Okay sir, ওটাই ডাউট ছিল. Okay, yes.
Next, number of terms in resultant polynomial. Resultant polynomial is known as capital R or P3. So in capital R, number of terms in resultant polynomial. Number of terms in resultant polynomial means number of temporary polynomials in resultant polynomial. Both are same, right? So NR should be equal to, NR max should be equal to m plus n plus 2. Okay, after correction. So I equal to 0, j equal to 0. If mn not equal to 0, you will understand later the significance of this if condition. Okay, so for I equal to 0 to n in steps of 1, to ensure this for loop is being executed for n plus 1 number of times, because starting with 0 ending with 1, total of n plus 1 number of times, corresponding to n plus 1 number of terms in first polynomial. ঠিক আছে, so n plus 1 number of n plus 1 number of temporary n plus 1 number of temporary polynomials we will get. How many terms in the first poly? 3. So how many temporary polynomials? 3. I is the index of the first polynomial. How many terms in the first polynomial? N plus 1. So right, this for loop should be executed for n plus 1. So starting with 0, we have to end with n, 0 to n, n plus 1. And this is the outer for loop, which is controlling the number of temporary polynomials as expected, we discussed earlier, right? Now in our for loop, for j equal to 0 to m in steps of 1, j is the index used for second polynomial. In second polynomial we have small m plus 1 number of terms, so this for loop should be executed for small m plus 1 number of times. So starting with 0, we are ending with m, ensuring n plus 1 number of executions. This is controlling construction of each temporary polynomial. So how many terms in each temporary polynomial we have in this example? 2. 1, 2. Why 2? Because number of terms in the second polynomial is 2, x and minus 1. ঠিক আছে, মিলে গেল? So in nested for loop, what we are doing? We are multiplying c1i and c2j. Coefficient of ith term in first poly, coefficient of jth term in second poly. The product of these coefficients is the resultant coefficient. And then exp1i plus exp2j. How do we multiply two terms? For example, x square into x. So if I multiply, this is your first term. I mean, let's say this is ith term. X square is ith term. And this is jth term, right? ith term and jth term. This is of ith term of first poly. So this is represented by t1i, and this is t2j. It consists of two parts. Its coefficient is 1, its power exponent is 2. Its coefficient is 1 and its exponent is 1. So this is your like c1i, and this is exp1i. ঠিক আছে, and this is your c2j, and this is exp2j. So if I multiply x square into x, the answer is supposed to be x cubed. Why? Its coefficient is getting multiplied with the coefficient of this. So 1 into 1, that is 1. And the exponents of the variable parts are being added. So it is 2, that is 1. So 2 plus 1, that is 3. That is the logic. So we are multiplying the coefficients to get the resultant coefficient. This is your C3, okay, C3, and the notation is, acha, it's a temporary C, and then the exponent. What is the exponent? exp. ঠিক আছে? So you are computing C, you are computing exp to get what? to get this overall thing. That means what you have computed according to this, one single such thing you have computed, x square into x. Next you have to compute this, right? So in the first inner for loop execution, you have computed x square into x. Then what you are doing, you are calling the polynomial construction algorithm function with C and exp in P. That is the P. So polyconstruct is the name of that function which is doing this job. What it is doing? It is, what is the term computed? 1 into x cube. So polyconstruct will take care of this term which is being just computed. Let me explain the second for loop iteration. Okay, then you will understand. So polyconstruct, so that is done. Then end for the holo. Now let's come to second for loop execution for j equal. So now j equal to 1. Okay, so j equal to 1 means what will be happening? This thing, x square into minus 1. This x square into minus 1. So x square into minus 1. X square into minus 1. Minus, this means this, and this means this. So what is the logic? C1i will be multiplied with C2j. The coefficients will be multiplied. So 1 into minus 1. How much? Minus 1. That is your C. Next, exp1i plus exp2j. The exponents will be added. 2 plus 0. That is 2. So this is your exp. Okay, so these two lines of algorithm are actually computing the coefficient and the exponent. These two values, minus 1 and 2, will be sent to polyconstruct function, and polyconstruct function will do minus 1 into x to the power 2, and it will add with this to calculate a temporary polynomial up to this part. See, 1x cube plus minus 1 into x square. That means what? X cube minus x square. Okay, so in our example, if we take this example, so here m is equal to 1 and here n is equal to 2, right? So if m is equal to 1, this inner for loop will be executed for j equal to 0 and j equal to 1. So only 2 iterations it will be running for, right? And up to this, what is the polynomial constructed? That is x cube minus x square. That is the desired fast temporary polynomial, x cube minus x square. ঠিক আছে? Okay, and who is pointing towards this so computed temporary polynomial? So this is being pointed by P. P is pointing towards this. With the help of P, you are constructing such temporary polynomial. See, here P is being used. So this is the explanation of the inner for loop. Okay, so in each for using the inner for loop, you are constructing each such temporary polynomial. And if you repeat this using the outer for loop, you will get all the temporary polynomials. ठीक है? All the temporary polynomials. So if now Now what you are doing, whenever you are getting such a polynomial x cube minus x square, you add this polynomial, so constructed with, okay, okay, let me, so this is the first iteration of the outer for loop. Let me go to the second iteration of the outer for loop. ঠিক আছে, second iteration. So if I equal to, for the first time when I equal to 0, this if condition is false. If I equal to 0, no, I not equal to 0 is false, so this if condition is not executed. So what is happening? Else temp equal to p. Temp equal to p means, temp equal to p means x cube minus x square, that is the first temporary polynomial which have been computed. P is pointing towards this and temp is also pointing towards this. ঠিক আছে, got it? Fine. Okay, how will you store this polynomial? These are actually pointers, so using linked list you are storing these polynomials. Okay, so else temp equal to p for the first time when I equal to 0, end for. So now coming to second iteration of the outer for loop, when I becomes equal to 1, and again j will be equal to 0 to j equal to 1, two times this for loop will be executed, right? So using this inner for loop, what will happen? This x square minus x second temporary polynomial will be constructed. So x square minus x, this second temporary polynomial will be constructed, right? And it will be again pointed by that pointer p. So this is lost. ঠিক আছে? Now what will happen? Poly construct, that is done. Next, if I not equal to 0, yes, it is true, because I is now equal to 1, 1 not equal to 0, it is true. So what is happening? You are calling polynomial addition algorithm or function. This polynomial addition is supposed to add two polynomials. What are those polynomials? One is the polynomial pointed by temp, and one is the polynomial which is newly constructed as a temporary polynomial pointed by temp. So these two polynomials will be added. So x cube minus x square plus x square minus x. What is the resultant? X cube minus x. So resultant x cube minus x is the so far resultant polynomial so far, and that is being pointed by p3. P3 is another pointer. So this is being pointed by p3. ঠিক আছে? Next, end. This else will never be active because I is no longer 0. Now what is happening? Next iteration of the outer for loop, when I becomes equal to 2, that corresponds to computation of this temporary polynomial for this example. Okay, so again using the inner for loop, what will happen? The third temporary polynomial will be constructed, will be computed, that is x minus 1, and that x minus 1 using polyconstruct will be pointed by p. So x minus 1 is have been computed just now and is being pointed by p. So this connection was lost. P is now pointing towards this, right? And then checking whether I equal to 0, not equal to 0. Yes, I is 2, not equal to 0. So what you are doing, you are again calling polynomial addition function, which will supposed to add two polynomials which are being pointed by temp and p. Let's see. Temp means, oh sorry, temp is supposed to, okay, previously I forgot to mention this. Previously temp was redirected to p3. So whenever p3 was computed, temp is supposed to point towards this, so this connection will be lost. Okay, So now at this situation, what is happening? Temp is pointing towards the resultant polynomial so far, and this is the newly constructed temporary polynomial. And polynomial addition function is supposed to add these two. Polynomials pointed by P, polynomial pointed by temp. So these two will be added to get a resultant polynomial as x cube minus x plus x minus 1. That is x cube minus x cube minus 1. And that will be pointed by P3. Okay, so the earlier connection is lost. Okay, and temp will be pointing towards this. Temp will now point towards this. Okay, temp is equal to P3. Then if closed, else closed, end for, and this for is terminated because this for is supposed to be executed for 3 times only. We have explained with the help of this example. So this is the generalized algorithm. This algorithm has been designed by myself only. I have not taken any reference from any book. You may find any match with this algorithm with any algorithm provided in some book. Okay. So this is generalized, and the program implementation I have done using this algorithm and is working very fine, very generalized. Okay, no issue. So you can trust on this. Okay. Okay. So after the completion of this algorithm, who is actually storing, pointing the final result? That is P3. So output P3. Okay? Output P3 means display all the coefficient and exponents starting from highest degree to the lowest degree. That is the meaning of for all are in capital N. Capital N is the resultant polynomial. And that's the algorithm development of polynomial multiplication. It's not a very tough task, just whatever basic fundamental thing we have learned in our school days, applying using that fundamental logic, we have developed the algorithm and the logic. It's very simple. Okay. Any query up to this, you can ask me. No issue. Any query, you can ask me. I hope it's clear now.
আচ্ছা স্যার একটাই জিনিস স্যার ইন দি এন্ড টেম্পটাও তো মানে ফাইনাল মানে রেজাল্টেন্টকে পয়েন্ট করছে তাই না
Yes,
টেম্পটা
yes. But
so sir we can print
we
temp
mean,
also
we mean to store when this temp is equal to P3. That, and you have understood why this line is required.
yes sir yes.
Temp is, the significance of temp is to store the intermediate, I mean, this temp is supposed to store or point towards the added polynomial at any
Yes, sir.
intermediate position, at any intermediate stage.
Yes sir, yes sir.
And P3 is supposed to point towards the resultant polynomial.
Resultant polynomial.
Yeah.
Okay. Okay sir.
Any other thing? একটু আস্তে আস্তে করতে হবে, তাহলে হয়ে যাবে, তাড়াহুড়ো কিছু নেই, ভেরি ইজি টপিক। আমরা ছোটবেলা থেকে করে আসছি, একদম স্কুলের ফান্ডামেন্টাল লজিকটাকে ইউজ করে পড়া হয়েছে, নো নিউ কনসেপ্ট। ওকে, so thank you for listening.